Konganadu College of Engineering and Technology, Department of EEE, Power System Operation and Control. Exercise number 6, Economic Dispatch in Power Systems. Next, these economic dispatch systems, the programs we are going to doing for the MATLAB software. First, to open a MATLAB window. Next, go to home pages using open for new script. After that, you have to type your program and save your same program using M files. Next, go to editor menu. This editor menu using run this program. In this program, any fault is occur, you have to it will be indicating for the red line for the command window. If suppose there is no error, means you can get the output values for this command window. Next, the economic dispatch in power system. First, aim to understand the basics of economic dispatch and solve the problem with a classic method without line losses. In this system there is no any transmission losses, only for this find outing for economic dispatch. Next, programs. Before programs, you have to discuss some of the algorithm. First, the step 1, read the program. Step 2, set the error for delta value. Higher value means 1 or 0. Assign any suitable value to set value. Check the whether the value delta value or this lambda value. Here maximum we are using for only lambda value. If suppose the value is satisfied, means you have to execute the program. Otherwise, this repeat for this step 15. So next step, step 6, we have to starting for the iteration plus 1. Next, calculating for P using coordination equation. Here the P means power demand. Next, calculate the demand factor, that means PD, maximum demand minus sum, maximum demand minus utilization of power, that is P indicating. Next, calculate the d lambda after calculating residual J using this formula. So here the d lambda for the J values, that is the conjugate one. The last step, calculate the total cost using formula. Total cost is equal to sum of alpha plus beta into P plus gamma value. So here this P means power demand. Next, programs. This program before we have to discussing for one exercise problems. The fuel cost function for the 3 thermal power plant are given by, so 500 plus 5.3 plus 0.004, 400 plus 5.4 Pg2 and 0.006, and then third equation 200 plus 5.8 plus 0.99 is the program problems. That means C1 is equal to 500 plus 5.3 P1 plus 0.004 P1 square. Similarly, C2 is equal to 400 plus 5.4 P2 plus 0.006 P2 square. C3 is equal to 200 plus 5.8 P3 plus 0.009 P3 square, where P1, P2 and P3 are in the megawatt value. The total load PD means the total generating capacity is 800 megawatts. Neglecting the line losses and generate limits, find the optimal dispatch and total cost of these given generating stations. These generating stations, we are going to find out the total cost of the power plant. Next, in this program we are going to using for the Newton-Raphson iteration method. So the alpha value means the given demand 500, 400 and then 200. The beta value is 5.3, 5.5 and then 5.8, that is called beta value. Similarly, gamma value, C1 equation, cost function C1 is equal to 0.004 P1 square, and then C2 value 0.06 P2 square. Similarly, C3 value 0.009 P3 square is the gamma value. So 500 is alpha value and then 5.3 is beta value and then 0.004 P1 square is gamma value. So this taking this value, we are going to type this program for using MATLAB software. So the first program percentage of iterative solution using Newton-Raphson method. Alpha value is 500, 400, 200. This is the initial value for this power plant, 500, 400 and 200. Then beta values for P1, P2 and then P3, 5.3, 5.4 and then 5.8. Next gamma value 0.04, 0.06 and then 0.009. So gamma value. So here PD means maximum demand of the power station. The maximum demand on the power station already given in these problems. Next del value. Here the del value equal to 10. We have to find out. If suppose not error means we can easily get the del value. Here percentage of error in del is set to high value. So we can choose for the high value. So next lambda. Input lambda into enter estimated value of lambda. So next this lambda value we are going to print. Next display. So lambda into P1, P2, P3. Here this lambda value P1, P2 and then P3. So next grade value and then d lambda value. Next iteration equal to 0, while ABS means delta P. Iteration counter, test for convergence and then number of iteration, how many iterations we need to solve these the given problems. So next P is equal to lambda minus beta bar 2 into gamma. Here P is equal to PD, maximum demand minus sum of power. So maximum demand minus power we are going to choosing, that means 500, 400, 200. It is the minimum power of using for this cost function. The total PD value is 800 megawatts. It's a maximum power demand. After that d lambda value and then display the d lambda value for P1, P2, P3 and delta and so finally end total cost we have to sum of alpha, beta and gamma value. This program, same program we are going to typing for this MATLAB software. So in this MATLAB software, percentage of iterative solution using Newton-Raphson method. So once you have to save this program. So once you save this program and give the run command. Here run command, it will be moved for this. Here untitled enter value of lambda. So untitled file enter estimated value of lambda. So already we have to type this have the output. So what is the value of lambda means 8.5. so we are here we are going to type 8.5 value, enter. So enter means we can get the output of P1, P2 and P3 and grade delta value. So P1 lambda means 8.5 and then P1 400, P2 250, P3 150 and then del value 0 and then lambda value 2263.8889. So the total cost of the given cost unit 6.6825 e power e plus 0.3. This is the output we can get the given problem for the using MATLAB software. So after that we have to the same output we can receive. After we have to choose this function, write the Viva question and finally get the write the result for this given program, right? Thank you.